Thank you for attending. My name is Ali Shaqlaih. I am at the University of North Texas at Dallas. Before I start, let me put the purpose of this talk first. First, I want to present what I did in my discrete mathematics class that I just taught in the spring. And then I want to open the floor for suggestions and on some teaching that approaches that you might have implemented in such a course, because I'm really interested in such things. And last, I will put some of the prospective teachers' perceptions about the IBL course that I taught. So some background, I teach math content and math methods courses at the university for pre-service teachers. I also supervise teachers in the field, what we call at the University of North Texas student teaching. And I've taught, I would say, many courses by IBL, like college geometry, complete IBL, math for elementary teachers, and math for secondary teachers. But this is my first time teaching discrete mathematics by IBL. I taught the course before, maybe a couple of times, but it was just the regular way. This time, I wrote by IBL. Students in the course are middle and high school pre-service teachers. So usually this course is offered for middle and high school pre-service teachers or for computer sciences. So in this time, all the students were either middle school teachers or high school teachers. And luckily, I only had 12 students in the class, and that's why I chose to do it this way. So. Calculus 1, as you might all know, is a prerequisite for the course. So all the students who are in the course have finished successfully Calculus 1. And the topics that I covered are, I would say, the regular topics that you would see in any such course: logic, methods of proofs, basic set theory, basic number theory. And these were just only using it for the way to prove things. It's not just for the sake of number theory or set theory. And then functions and relations. I didn't use an IBL text, and the reason is because I was really hesitating to do IBL or not. So I used Discrete Mathematics, an Introduction to Mathematical Reasoning by Susanna Ebb. And I also used some of her notes that she sent me, including some project ideas and worksheets and something like that. You know, this course is for pre-service teachers, so always my concern is for two things. First, the math content. You want to make sure that the pre-service teachers get the math content, especially in such a course. In particular, middle school teachers, because in our campus, this is the last math course they take for middle school teachers. Of course, high school teachers, this is the first serious math course they take. So I really concerned about the math content from one side, but more importantly is, you know, when you teach pre-service teachers, in my opinion, you want to make sure that these teachers or pre-service teachers will model you in their future teaching. So you're not only teaching the content, you're also teaching methods, even though it's a content course. So usually research shows somehow that teachers tend to teach the way they were taught in high school or in middle school. Sometimes even I see it in myself. When you remember how you were taught fractions, for example, you try to teach it sometimes the same way. So I try to make kind of change in that sense. So the first time I decided to do the IBL, I said, you know, this course is kind of different from like a college geometry course, where things there, you know, you have manipulatives, a lot of stuff to do, problems to solve. But in such a course, it's just how to write. And I was wondering if I can do IBL in such a course. It's just about writing mathematics in general. So I said, well, let's not do a pure IBL, just use hybrid, what we call hybrid IBL, which is kind of a combination of the regular IBL, just with some brief lecturing at the beginning. So it was not completely IBL. I would say it was maybe 65 IBL, because at the beginning of each class, I give some notes, sometimes some definitions. We discuss as a whole class some concepts first, and then we do IBL. So the teaching approach I would describe that I used is a brief interactive lecturing with the clicker questions, usually at the beginning of, let's say, maybe about 10 minutes, and then group work, presentations, students on the board, all the things that we use in any IBL teaching approach. And in this course, well, most of my classes, but in particular in this course, I try to convince the students that knowing the thing is different than writing it. So usually I start asking the students, can you define a point? And then, of course, they will be challenged because they can't define it somehow, because, even geometry is undefined points. So I try to drive them to a point where, well, even though you know what a point is, you're not necessarily able to write what a point is. Or can you define a line? Or can you tell me what do you mean by two lines are parallel? Something like, basic facts. And from there, we go, this is all in the first meeting, so I don't basically teach. The first meeting just goes for discussion like this. And the purpose is to convince the students that they need such a class, that they already know all this, point, slope, all these things, but not necessarily being able to communicate it then to their students. So another question I usually ask, which is larger, 1 or 0, or 2 or 1? And then they will say, for example, 1, of course. Can you tell me why? And of course, they will panic. And then we go from there. These are the things that we will try to learn in this course. Basically, the big goal of this course, in my opinion, is to teach the students how to write. There is no, in my opinion at least, there is not much content that you worry about compared to other courses like Calculus 1 or Calculus 2 or even Abstract Algebra. Here is just, if the student get out of the course with being able to reasonably write proofs, then I think it's okay. So I will touch a little bit on some of the things that I do in some certain topics. For example, in the proofs, I used to give, for example, proofs and ask them to fix where's the gap in the proof. So, for example, put them in groups. As I said, I only had 12 students in the class. So 4 groups, sometimes even 3 groups, so it was easily managed. So I will distribute some worksheet that has written proofs, and I'll ask them to comment on the proof and fix it if there is any wrong thing. Also, I used to ask students to go to the board to do the proofs while others are monitoring them and asking them to change things while they are working. Another thing that I used, I called portfolio, which luckily I was able to do that because of the number of students. I only had 12. So portfolio, each week, I will give the students a set of problems. They were supposed to work on it, write the proofs, and submit it to me next week. I will grade all of the problems, give a grade of A, B, C, or D. And if the grade is not A or B, I'll ask the student to do the problem again. And when they submit next week, they submit the new solution, and then the grade for that particular problem will be the average of all the grades that they got on that particular problem. That way, by the end of the semester, every student hopefully had all the problems, hopefully graded by me, and some close to perfect proofs before the final, and that helps them to prepare for their final at the end of the semester. For the relations, I tried my best to use real-life examples of what we call relations. For example, relation of a brother of, a father of, sister, something like, and is it symmetric, not symmetric? How can we make it symmetric? For example, the relation of brother of is not symmetric, and how can we make it symmetric? Siblings, or some father of, is it a functional relation? Something from daily life. So hopefully they will reflect this approach when they start teaching in the middle and high school. For mathematical induction, I tried my best to convince students why this axiom, if you like, works. And there are many ways one can introduce this. One of them is a line of people, and there is a stick. The first one has it, and the game is each one has it, will pass it to the next, or the ladder. If you go up, you have to go step by step, and then discussion. Are you convinced that everyone on the line eventually will get the stick? Something like this nature. How did I evaluate the course? Well, presentations, as I said, portfolios, regular exams, first, second, and final, just traditional exams, and quizzes somehow. This is a sample project that I got from Susanna Ebb, which is talking about the proof of Fermat-Little theorem. This is on YouTube. So I asked the students in groups to look at this is about, I don't remember, 50 minutes movie or something about documentary about the proof of Little Fermat theorem. So I asked them to look at it and write a report of 1 page about what they see, how people, how mathematicians go, and how sometimes you attempt so many times to get the proof. Even sometimes you think that you get the proof, which what happened in the proof of this theorem, but later on you realize that it's not right and you go back and correct. So that was kind of mathematical proof. Second, a project that I also asked them to do is about some kind of documentaries about teaching 8th grade math in several countries. So we chose one of them that was, I remember, in China, about 30 minutes video where teacher is teaching 8th graders. And in that particular, it's talking about going inductive wise and how the counterexample and how it's working or not working. So, and ask them to reflect on that. So my challenge really was the motivation for the students, and that's where I'm asking you now to maybe think for a few minutes, maybe 2 minutes or so. How do we motivate students in such a course? It was a big challenge for me to motivate students. They're coming from calculus-based, so they try the problem for a minute. If it doesn't work, they give up somehow. Because this is a different course than even if they finish linear algebra. Some of them finished linear algebra before this course, but still this course is different for them. And the second challenge is, how technology, sometimes not good nowadays. They try a minute, and sometimes without trying, they go to Google, and they Google anything, basically they find. Well, I tried to basically not allowing them to use it in the class, but the problem I realized that outside the class, they use it. So for example, I give them a bonus. An hour later, if they are outside the class, they will come with a solution. Whereas if we do a review session where I give them the problem and without any resources, they panic. And of course, clearly that's because they use the internet. So I'm going to give you maybe 2 or 3 minutes to come up with some kind of techniques for motivation in IBL courses, in particular in such a course if you have done so, and then we'll talk about it. Any feedback or suggestions? Go ahead, please.
Melvin Jeter, Illinois Wesleyan University. About the Google question, it's pretty simple. At my university, I put it in my syllabus what plagiarism is. I define it and make it very clear that if they present somebody else's work, it's plagiarism. It's most likely a failing grade in the course. It's a report to the associate dean, and at that point they get a warning letter. If it happens again, they're removed from the university. So at least at my school, that's a pretty easy thing. And another thing about Google, it cuts 2 ways. When you get a proof that looks a little suspicious, you go online and Google it, and sometimes you find it word for word, and so it kind of cuts 2 ways. So
yeah, sometimes they change it somehow, but still, yes, you're right. Yeah. Thanks. Other feedback, suggestions? Okay, last thing, I wanted to present for you some of the students' perspectives. So these perspectives came from 2 resources. At the end of the course, I asked all the students to write a reflection, and also I got some of the student evaluation. So, for example, it helped me understand better, need more of these courses. Presentations made me confident about my teaching ability. I think different now. I am more careful in my writing. I do like the fact that we are able to present and share because he made it comfortable for the students and me. And the course content was challenging as well as enlightening. I enjoyed how such simple concepts could grow into things we see all the time. Very interesting course, and I've learned so much that I feel like ready for harder math classes. And finally, a lot of inquiry-based learning and wonderful role model for us future teachers. So I really was surprised of the good feedback I get from students. At the beginning of the course, I was not sure, even because when I first used IBL in math for elementary teachers, some of the students went to associate dean because, you know, it was very challenging for them. For this course, it was really a much better experience. So my recommendation will be just try it, even in such a course. It's challenging, but it's really good experience. Questions?
Bill Donnell, Illinois Wesleyan. I want to know what the course name and number and a description of the course is. All the math people take it, all the math for education?
That's a good question. First, the course called Math 2000, and it's only this particular course called Discrete Mathematics. It's aimed for middle and high school teachers. We used to have a course called Math 2770 for computer sciences, and we used not to have such a course. Students will go just to real analysis, and the problem there was we'll spend like a month or so doing this, so we don't have time to do real analysis. So I proposed a year ago this course, which aimed only for middle and high school teachers. As I said earlier, for the middle school teachers, that's the last math course they take. For high school teachers, that's kind of the beginning. You know, after that, they take the number theory and the real analysis, but it's no computer science students there. That's why we can emphasize a lot in how to write and how to prove rather than going to algorithms and graph theory or something like that. Yeah, please.
My name is Josiah Kreutz from Omaha. And you mentioned briefly something about relations. I was wondering if you could go into more detail about how you can give students maybe more of an intuitive understanding of some of the really tricky concepts in discrete math.
Yes, the way my approach was, I want the teachers to have some daily life applications or real life applications of what we're talking about, even when, for example, we ask them to distinguish between a function and a relation. So my approach was, well, let's talk about relations in our daily life. For example, you know, the problems in the book, most of them are this relates to this if they have same number of digits. They all kind of abstract thing. So I tried my best to use kind of relations that we all know in our daily life. You know, X is a relation with Y if X is a father of Y. And then is this relation reflexive? Is this relation, you know, transitive? And then is this relation a function? And how can we make it a function? You know, all these kind of questions and discussions. You know, for example, we get one question and then we spend 10 or 15 minutes on such a question, just trying to go deeper in it, like what kind of relation is it? And is it a function? How can I limit the domain, for example, to make it a function if possible? And, you know, examples like that. But I will be happy if, you know, anybody tried something like this, because in my opinion, that's one of the important things in such a course, especially for middle school teachers, because they don't see where to use this in their teaching. So one thing, you need to convince them this is applied, this is needed. You need this in your daily life, and here's where you can use it. Any other questions? Thank you very much for attending such a late talk. Thanks.